All right, I think it's recording. Share the screen. All right, so I'm going to go to the prompt here. Okay, so we are going to deploy our models. Okay, we're going to deploy in particular this wine quality related data set and models. So I'm going to go to the Jupyter notebook that we had, and we're going to use that basically to start deploying. If you remember, I had said that we were going to, for deploying our models, we were going to use ONNX and also GitHub, right? So I had asked you guys to create your GitHub accounts, right? So you should have those, and we're going to be deploying there. So the advantage of deploying to GitHub is that we will have, it's going to be available on the web, basically. So your models are going to be deployed and you'll be able to use them over the internet. So we're going to have to use a little bit of JavaScript, HTML, and CSS just to kind of build the interface, which will be a very simple form. So if just to give you an idea, the wine quality data uses 11 inputs, right? So what does that mean? We need 11 text boxes. And then we're going to have a button. We're going to press the button, and we're going to invoke some JavaScript that will use the ONNX framework just to process our models, basically. And that's it. Okay, so it should be pretty simple, straightforward. For deploying websites on GitHub, we need to use something called Pages. So GitHub has a thing called GitHub Pages. Okay, and so we'll be using that as well. So let's start with navigating, okay, to your Jupyter notebook. So we need to activate the environment. Okay. Okay, and you guys are section 1. Okay, so kind of activate Pi37, ITS 521, right? So you guys are one day. And then we're going to go to your folder. Which should be ITS 520 fall 2023 S1, section 1. Okay, so here then we need to be okay, so it's I think it was in data that I had done this. So there's the wine quality data. Do you guys remember the name of was it regression linear PyTorch? Was that the name? That was our Jupyter? Okay. All right. So yeah, we just need to use the Jupyter that you use for your homework, basically, right? You know how to do that really well for the competition. You've generated your R squares with both the neural networks and the XGBoost. And now we just need to deploy those models, and really deploying them from the Jupyter should be very easy, right? The hard part, or not hard, but the more work will be to build the interfaces on the web. That's really the what's going to take work today. But this is easy. It's almost done. So we can go ahead and start our Jupyter notebook from here. We will need to run it again. So obviously, so that it runs fast, I'm not going to do that many iterations. R square will be low. Obviously, when you're doing it, you would run it for a long time to make sure you get a model that has the best R square possible and deploy that one, which should be logical. Okay, so let's go ahead and click on this one. Okay, so I'm just going to look it over. So here we have our neural networks that we have used. And we have, yeah, so that's basically the neural nets, then the XGBoost part. And I was at 43 or so, right? So this is kind of where we need to be. Okay, so now we're gonna go ahead. I'm gonna do two things to this so that it runs fast. The thing that delays us the most here is running a lot of epochs, right? So I'm just gonna run 100. That should run pretty quickly. It'll be a bad R-square, but at least it'll give us a model that we can deploy. Okay, and then you would just have to run it faster, or with more epochs later. I'm also going to reset the kernel here. I'm going to restart and clear output. Okay. All right, so now we can just run this. And basically, I'm going to follow the logic of this Jupyter notebook. So first, I'm going to deploy the neural networks. One, because there could be another scenario as you're doing work where neural nets do better, or you can't really apply XGBoost for some reason, or random forest. So, but here I'm going to show you that we can deploy. Basically, you could deploy the random forest, any sklearn, basically. You can deploy XGBoost. It's its own thing, but it's kind of made the same way as sklearn. And then the neural nets obviously are PyTorch. So PyTorch has its own way of deploying. What are we using to deploy? We're using something called ONNX. That's the ONNX. That's a framework created by Microsoft. So a lot of companies like Google, who has TensorFlow, have their own ways of deploying TensorFlow. But Microsoft, obviously, they don't have a framework like PyTorch or TensorFlow, so they create more open things, right? In this case. So they've created ONNX so that you can use that framework to deploy all kinds of models to the web. Nicely. All right. So let's go ahead and run our code. So first, the libraries, right? So obviously, as you might imagine, we need a new set of libraries to be able to deploy. So we're going to need the ONNX related libraries. So here we're going to add the pip installs. So I'm going to do exclamation pip install ONNX ML tools. Do you guys see that? All right, so this is one of the two libraries that we're going to need at least to deploy our models. So I'm going to run it, give it a second to install. All right. Any questions? Okay, so I did it, I think. Great. Now I'm going to comment this one out, and I'm just going to add the second library that we need, which is ONNX runtime. So I should say that, a lot of, this is a very common thing in AI, right? In AI, especially today, there's a lot of competing groups. They develop something, and a year from after they release one thing, they release another thing, and they make the previous thing obsolete almost, right? So it moves really fast. So there's actually, the story is that there was just an ONNX, and now there's ONNX runtime. So they're actually call it 1.0, 2.0, but ONNX runtime is the one that they're supporting more now. So just be aware of that, but I'll show you both basically. And, just be aware of that. Probably if you were doing a project that's really important, etc., Google and see where they are at, because they could have a newer version, but otherwise you probably want to use ONNX runtime. Okay, just be aware of that. All right, but both work. So the next one, let's do exclamation pip install ONNX runtime. Okay, just like that. Hit run. And same thing, we're going to wait a little bit. And that should be all the libraries that we need, hopefully. And then we're just going to import these. The code, as you know, it's already on GitHub, so you can just get it from there. So let's give it a minute. Okay, so did it, I think. Yep, it's done. So we can comment this out now because we don't want to run it every time. But we've installed basically the libraries that we need. And these are actually just libraries for XGBoost because PyTorch already has its ONNX libraries built in. So we can just hit this here, just load these. Run these. Okay. It's taking a while. Not sure why it's taking so long. Oh, there it is. Okay, let's run this one. And then let's add let's add a cell here. Okay, so it finished XGBoost. And now we're just gonna import the modules that we need to be able to export as XGBoost. All right, so we're gonna do import ONNX runtime. ONNX runtime as RT. We're also going to import ONNX ML tools just in case we need it. ONNX ML tools. And we're also going to do from SKL to ONNX. Oh, sorry, SKL to ONNX dot common dot data types import float tensor type. Okay, so these should be the only three things we need. Although there's many modules, etc., that you could use, right? These are the things that we need. So let's run this, see if it works. Okay, no errors. Good. That's good. All right. Now in parameters, as I said, I'm just going to reduce the number of epochs to 100 just so that it runs a little bit quickly. Really, our only concern is that when we've deployed the model, we're going to enter 11 inputs, get an output, try another set of 11 inputs, another output, and then from there, we know it's working. It's predicting, right? So now this I've changed to 100, so that should be fine. So hit run. Okay, we've got the parameters. Then the rest, we're just going to repeat basically what we've done before. So there's nothing new here. We're just going to read in our data, our wine quality data. We can print it out to the screen, print the headers list. Like that. Correlation matrix with the heat map. Okay, so we've done that. Then we're going to start processing the data. This is just the same thing and train our model, right? So we just repeat this. We don't have to change anything. It's basically what you did in the competition. Okay. We've done the normalization or standardization, sorry. You guys tried that out. Create the data loader. And then our neural network architectures, as we previously described. Okay, so the train loop. Okay. And then I'm just going to use the linear plus nonlinear. Really, this is up to you to decide which model was the best that you want to deploy. Okay. But it wouldn't matter. Any of these can be deployed. Okay. That's the beauty of this. It's like you can do any architecture and just it's in model and you'll deploy model. So it works for all. Okay, so let's start the training basically. Let it train for about 100 epochs. Let it do that. Right, so let's let a few more epochs to go. And it should finish in a sec. And then we're just going to evaluate as we usually do, get our R square. This is where you would choose the best one, of course, that you want to deploy. What matters is if you look, we have a whole bunch of architectures, but really you can treat all models as a black box because what do they have in common, regardless of architecture? They have the same input vector and the same output vector, right? And as long as that's consistent, you don't even have to worry about what's inside the neural net. So now we can proceed to evaluate and get our R square, right? So there it is, 29. That's, of course, low because we're not running that many epochs, but you guys have achieved as far as 43, I think, in your R square. All right, so then go ahead and, complete. We can print the plot. There it is. There's our plot. And now the rest would be XGBoost, but I want to keep these separate. So first I'm just going to do deploying the neural nets, right? And then we'll come back and deploy the XGBoost part. So then here you could assume you're done with the neural network. You have it now, right? So we're going to add a few cells here. So the neural net, where's the neural net? The neural net is in model, right? In model. So that's the thing that we want to deploy. Does that make sense, guys? Right? It's in model, right? Model takes in a vector of what size? What's the input to model? A vector of what size for this? Not epochs. I mean the input, right? What input goes into the model? We are trying to predict wine quality given an input vector of what size? 11, right? That has the value. So for a specific wine, we want to determine the wine quality. Please don't forget that. That's really important, right? This is why we go back to the very beginning of the semester. That X and Y matrix. That's it. That's the key to all. That's almost like the secret to machine learning, right? That X and that Y, know those dimensions in your head. Never get confused about that. And then you can see we can play with many architectures. We have metrics to tell us what the best one is. All right, so I've got my value here. I've done all the evaluation and I can deploy my model. So then this is what's new now. I'm going to call this deploy. and I'm going to say PyTorch models. And you can deploy even like GPT models, right? So obviously there's one limit there. If they're really large, GitHub only gives you 25 megabytes. So it limits the size of your files to 25 megabytes. So that's the only problem. So if you have a very large model from PyTorch that's more than 25 MB, it's not going to fit. So then, because they want you to pay money, right? It's like for something bigger. But really, if you have your own web server or something, then although that, that has security things, but you could deploy that way. All right, so deploy PyTorch model. That's the part we're doing right now. So I'm going to do cell type markdown, hit run. And as you will see, the code is actually pretty easy. It's just a little bit of code, right? So one thing we're going to change. Now we know that the model is in what? The variable model. It's there. So we're going to change the state of model from training to eval. That's the first thing. So you can just do eval like this. This changes the model so that now it's like, it's got efficiencies to be used just for prediction and inference. Remember that this is usually n by 11 is the size of the input. That means you can take one vector, 100 vectors, either one will work. Okay, the example I'm doing is for 1 by 11, so one vector, basically. All right, so we're going to proceed. So after changing it to the state of eval, then we have to define a few parameters. The first one is, what does the input look like? So we can call this one dummy input. And we're going to say that it's a torch tensor. And we're going to say right now that it's just random numbers, and we really just need to specify the size. So the size here will be 1, 11. Okay, this is important. All right, 1, 11 is, you're going to define that that's going to be the input, so that when we write the code in JavaScript, you will know how to write it. Okay, so 1, 11. And then we're going to have both. We need to define names for our inputs and our outputs. So we can do something like input names equal, and then we can just say input 1, because we may need to, when we're getting variables, once we deploy the model in JavaScript, we need to invoke them by name. So we need to have a name as reference. So in this case, we can do also output names equal. And then this is going to be output 1, for instance, just some name. Okay, got it? All right, and then after that, it's pretty straightforward. We really just need to call torch.ONNX.export. Okay, and we're going to specify some parameters here for our model, so like the name of it, etc. So we're going to, what are we exporting? Obviously, the model, and the model is in the variable model, correct? Then we want to tell it what an input looks like, so we can just add dummy underscore input, comma. Then the name of the file. So what do we want to call it? Since this is a torch model, let's just say DL net, although it was an F1 plus F2, right? So you want to be very specific of which model you're deploying, etc. But it's any name you want to give it. So DL net wine data. So that's going to be the name, and it's going to be an extension ONNX. So this will generate a file, which is a binary file. You can't like double click. I mean, it doesn't work that way. Instead, it's just a file that you're going to upload to your GitHub. And then your JavaScript basically will grab that file, and there you go. That's your model. It's pretty easy, right? Pretty simple. Like I said, it's really nice. And if all of deep learning, like even ChatGPT or GPT models, GANs, etc., were very small, then it would be super easy to deploy AI on the web. The limit is that they're very big models, like too big, right? But if you think about it, this is kind of what GPTs are, except they have, they have this prompts and all that stuff as well around. All right, so DLNet wine data .ONNX, comma, right? And that's going to be your output file. You can set it to verbose, true or false. Let's just set it to false. We don't need to see any output data. And then just specify what the input names and the output names are. So you can say input names just equal to your variable input names, comma, and then output names equal. So let's actually do right like that. And this is going to be output names, just like that. Got it? So now we have, that's it. That's it. Good job. All right. So you now know how to deploy an ONNX model. So we're going to go ahead and run this one. So I'm going to save it and then hit run. And I didn't see any errors, right? So if there's no errors, then we should go over here. And now there should be a file, dlnet wine data.onnx. Do you guys see that? And that's it. That's your ONNX model deployed. It's great, right? The size of it is 2 KB, pretty small, right? Very efficient. So you can build a model up to 25 MB and deploy it on GitHub. Anything bigger than that, you'll have to pay or something at GitHub or figure out how to do it. But it's, the limit is really your web hosting provider, if you will, that kind of thing. All right. Yeah, so we're only going to do the PyTorch part now, and then we're going to do the XGBoost part. So don't delete, don't like stop your code or anything like that. Leave it here, and then we'll come back, run XGBoost, and I'll show you how to deploy XGBoost. I just don't want to confuse you, okay? So for the PyTorch part, which means all the neural networks, this is all you have to do to deploy your ONNX model. And now we can switch over to the web to do our web development and deploy our application. Any questions? All right, so I assume the model is there and done. It's going to be in our folder here, DLNet wine data ONNX. So now I'm going to switch gears to GitHub, because we're done basically with these PyTorch models. We are done here. So, okay, so I need to open GitHub. Okay, so I'm going to my GitHub. Okay, I'm already logged into my GitHub. I asked you guys beginning of the semester several times to create your accounts. You need to be in your GitHub. You don't have to pay for this. This is free up until 25 megabytes. And this is called Pages, okay? So I'm going to go to PyTorch over here. And deploy to production is, this is my folder. Obviously, you use whichever folder you would like. I'm going to go, I'm deploying them here. Now, I've already done this with the other class, right? So I'm just going to create a new one, and I'm going to call it like section 2 wine quality, okay? This is going to be your folder, so I don't miss any steps. So let's go ahead. Now, I'll show you how to build in GitHub efficiently, right? Obviously, GitHub has a lot of command line things, but we're just going to do everything here on this GUI interface, okay? So what you can do is here in deploy to production, I want to create, first of all, a new folder. I'm going to call it section 2 wine quality. So I'm going to go here to add file, okay? And I'm going to say create new file. And then here, I'm just going to say section 2 wine. Oh, no, you guys are section 1, actually, right? It's your Monday. So section 1, wine quality. And then you can do / and then you can do just a README. So really what's happening is I'm adding a file, but I'm using a trick to create the folder itself. Okay. So I can do then just add something here. You can say like section 1, wine quality. ML deployment. And this is what we're going to use to deploy both of our NNs and also our XGBoost models, okay? So once that's done, you can just hit commit changes, hit commit again. Any questions? Everyone with me? You're not with me. What's your question?
I've created a repository, went into it, and there's nowhere to add files.
Okay, so imagine that I assume you're like here, right? You can get to here.
Yeah, I was just one past.
Okay, so then you must have a repo like mine called PyTorch, right? Click on that, please.
Actually, no,
No way.
I don't have any repository yet.
Oh, you've never had a repository.
Right.
You don't know how to create a repo is what you're saying.
Well,
Yeah. I think I get you. So to create a repository, click on this tab, repos up here.
Right.
So I was assuming everyone had a repo, right? So click on repos and then see this green button here that says new?
Yeah.
Click on that one.
Okay.
And then just create a repo.
Okay.
I just don't want to create, I don't want to create a default repo. But you go ahead and create one, give it a name, no spaces probably. And then once you do that, I'll be like commit or enter.
Repository.
Yeah, probably.
Okay. Put that there.
And then if it's not asking you for anything else, you can just go back to your main username, and then you should have a repo now.
Yeah, I got the repo there.
Okay, so assuming you're like here and there's like a repo here, right?
Yes.
Okay, now click on it. Like I click on this one.
Okay.
And there's nothing in it, but you are in the repo, correct?
Yeah, I'm in the repo now. Yeah.
Okay, so do you have now these buttons here?
No.
Go to file, you don't have that? Really?
Yeah.
All right, well, it's 6:19 anyway. All right, so let's take our 10-minute break. Let's come back at 6. I'll help him out. And we'll come back at 6:30 and finish up. Okay, so let's let me